I'm actually going to do a presentation from an end user's perspective rather than a researcher's perspective. This has been a really great project. It's involved researchers, end users, international collaboration, and most importantly, industry. And I really want to actually spin it around. I actually want to acknowledge industry participation at this workshop. I've been harping on poor Martin and John Lovett and Michael Robinson for a number of years saying, we need to have more bloody industry people here. And so I'm very, very pleased to thank you, 5, 6 industry people from the strawberry industry over there. Thank you very much for attending this and giving the support. So hopefully I'll get an invitation to the Christmas party again. So, okay. Now, whoops. All right, so what's the current challenge that we're facing? So I used to work for the post-entry quarantine group, and a lot of the current testing programs based on generic approaches, visual inspections, particularly for fungi and bacteria and viruses obviously, bioassays, biological indicators, and electron microscopes. So that's a generic approach. We also use serological and PCR tests. So that's all been dandy. Much dandier than this. So what's wrong with the way we're currently doing the testing? Well, many of the tests are slow, they're very ambiguous, particularly the bioassays. Picking on the strawberry industry, we use what's called University of California strawberry indicator plants. You can't tell if it's a virus or if it's a nutritional symptom or just a physiological issue. And there's many, many, many tests that we currently apply. For citrus, for instance, in excess of 20 different tests are applied just for the viruses, and it takes in excess of approximately 3 years to screen a citrus plant. By the time the industry get it and then propagate it up, you're looking at close to 10 years turnaround. It takes forever, and it means our international competitiveness is being jeopardised. As I said, bioassays produce ambiguous results and also require substantive glasshouse space, which is expensive. The other challenge with the existing process is that we actually need to know what we're trying to target. To develop a PCR, you actually have to know what the virus that you're trying to target. And then you need to do validations for many hundreds of different tests. And particularly in bioassays, the global expertise, not too many university students are studying bioassays anymore. So relying on people like myself who are sort of getting to the end of our sort of careers, and that expertise is slowly dying. So in 2013, the journey begins. So just recapping, Australia had 3 prime ministers during that year. We regained the ashes for the first time, and no sticky tape was in sight. My department was called AQUIS, and Victoria was, I still don't know what they're called, so sure they're called something that is captured in that acronym. But I was invited by Michael Robinson at the time, very courageous Michael, to present an end user's view on what are the R&D challenges that I, as an end user, would like to achieve. And so I challenged the audience at the time to develop one single test to detect all plant pathogens. And most people in the room, rightly so, thought I was a bit crazy. But there was a few people, including Jane Moran, we've already mentioned Jane, Brendan mentioned her, and Brendan Redoney and a few other people from PBCRC and researchers from Murdoch and ourselves in New Zealand, and we all got together and initiated this project. And I'll just quickly go through some of the outcomes of this project. So we decided to use a small RNA approach rather than a total nucleic acid extraction process. And we're basically exploiting the plant's immunoresponse. And you can see in that the bottom figure there that this process actually has been demonstrated to pick up all different types of virus particles. And I won't go through it. I'm sure most of the people in this room are much more expertise in this sort of area than I am. But as a result of this, and working with Roberto, who's been absolutely fantastic, and Catherine and the whole team at Murdoch University, as well as the New Zealand colleagues, another great group of people, and obviously our own internal Adrian and Joe Mackey, we've actually demonstrated some really good outcomes from this. So, outcome 2, we started comparing next-gen small RNA approach using known virus-positive controls. So we know what those viruses are based on our post-entry quarantine testing. And so we know what all the viruses are in there because we've done post-entry quarantine testing. So obviously, that's going to be 100% correct. No, it's not. And so next-gen has already started to demonstrate that it can pick up a few more viruses than just the existing protocols. And this is my point, that next-gen offers our country and other countries opportunities to pick up much broader scope than some of the existing platforms. Well, I don't think we should ever forget that. But, so then we started actually using and acknowledge importers. So we've approached, when I say we, the royal we, it's Adrian's approached a number of our importers and started testing unknown samples. So we started testing samples using the existing post-entry quarantine protocols and then comparing them against next-gen. And it's about 98% agreement between the tests, which is positive. Post-entry quarantine methods found about 22 out of the 50 plants, while next-gen's identified about 24 infected plants. Of those, next-gen detected about 74 viruses, viroids, compared to only 43 by PEQ. However, next-gen did fail to detect grapevine fan leaf, and so we're doing some further investigations to explore that a little bit further. So again, it just highlights that this technology, whilst we've still got a bit more to develop, it looks like it's going to be a real winner. Further outputs from the project is a number of publications. We've got a user manual that's in draft form, where Roberto's just finalised and submitted the final report, and we've also put together a draft policy paper, and that's sitting with our policy colleagues in Canberra at the moment. We've actually already adopted next-gen, pretty radical, but we've actually adopted next-gen already for clonal grasses imports. And the reason being is because the existing platform, it's just so leaky that we discussed with our policy colleagues and they said, yes, let's go for it. And we've also run numerous training workshops and also a number of industry seminars. So some of the benefits of next-gen, it improves the detection. No prior knowledge of the virus or viroid is required. It's also a lot more cost-effective. Brennan mentioned about $100 or $200. We estimate it's a little bit more than that at the moment because of the associated visual screen that's still required. But compared to about $3,500 to $4,000 per cultivar using the existing PEQ diagnostics, you can see it's really beneficial from industry. But the money is important, time is more important. And so it's got scope to reduce time. Down to months compared to years. And this is where industry's been harping on me for 20 plus years. It takes too long in quarantine, Mark, get it down. And this is what's driving us to do this. By getting it faster access to plant genetics, it will improve our industry's productivity, sustainability and global competitiveness. It can also identify new and emerging threats as we demonstrated in those previous results. I had the opportunity a couple of weeks ago to get up at 1 or 2 in the morning to present at the Rome IPPC meeting, and I presented this concept that next-gen, it can be done anywhere around the world. And so there's this concept of a global plant passport, whereby a country can test a plant using next-gen, and if it's maintained in high health, There's no reason why post-entry quarantine should be required anymore from that point. So it's a bit of a radical idea, but it's got potential. So why haven't we adopted this great tool? So the project's demonstrated proof of concept. But like any new transition, we need to understand some of the limitations and address some of those critical control points. Brandon's already mentioned about sampling, always an issue, even now. Interpretation of data. We've got sequence data. It hasn't got any biological context. What does it mean? We need further evidence of the efficacy of next-gen against the current diagnostic platforms. We need to compare next-gen against PEQ. We need more detailed technical guidelines, and we need to build the National Plant Biosecurity Diagnostic Network capability using next-gen. We've also need different IT and bioinformatics skills. They're not traditional plant molecular or plant pathology sort of skills. We need to employ more people like Roberto. You owe me $20 for that comment there, Roberto. Because now we're analysing gigabytes of information. We're not looking at microscopes anymore. The biggest thing, though, is that there's a lack of a regulatory framework for decision making. And this will be the key outcome, hopefully in the next year or two. So how do we go about adopting this technology? So we need to take it from the research laboratory to the routine diagnostic deployment. So we need to optimise the standard operating procedures. We need to compare, is small RNA the best approach? Should we be doing total nucleic acids? We need to look at sampling issues. There's a whole bunch of bioinformatics pipelines out there. Which one should we be using? We need to build an end-to-end quality assurance program, literally from, as Brendan said again, from sample preparation to the end of bioinformatics analysis. We need a lot more comparison we need to give industry and policy regulators confidence that this thing will pick up the viruses and viroids of concern. We need to conduct further training workshops Peter's just about to throw it up. Go, Pete. Beautiful. We've got to need to provide more training workshops for the National Biosecurity Diagnostic Network. And then we need to do some proficiency ring testing to verify competency. As I said, we need to develop and implement the science-based policy in conjunction with regulators. And then we need to conduct, throughout this whole process, we need to conduct more industry engagement to give them broader awareness of what this does and confidence that it does actually work. And as a result of this, to actually get this implemented, at 4 o'clock this afternoon, I've got a project team meeting with Penny Measham from Horticultural Innovations Australia and Joe Luck from Plant Biosecurity Research Initiatives. 4 o'clock at table number 1, we're going to meet. And then we'll have a bit more of a chat about where we're going with this. Whilst we're waiting, just to sort of wrap up here, this is a concept that a strawberry expert over in America presented a little while, and I've sort of pinched his idea more or less. So imported plants could come in. We could actually test these on arrival using next-gen. If it's a negative result, there's potential that we could actually provisionally release that material into a quarantine facility while industry can propagate that up. And then at the same time, we continue doing the bioassays and the PCRs and the existing diagnostics. If that's a negative result, then we release the plants. If next-gen shows that it's a positive result, we could then heat treatment or destroy at the very start. So just the final slide here, learnings from the project, set realistic goals and timeframes. I think we were a little bit ambitious with our goals, particularly implementation. Engage all key players, particularly change managers. I tried to get policy, my department involved. I should have persisted a little bit more because that was a mistake I made. This is really key for every project, R&D project. It's great producing an R&D, a research paper. Well, that's nice for the researcher, but it doesn't help the end users. Implementation takes as long, if not even longer, than the research component. We need to factor that in. communicate regularly with the project team and stakeholders, including industry, and then repeat. One of the things that I absolutely enjoyed about this project is working with the research community, international collaborators, and government. And on that note, I want to finalise everything and say thank you very much for a great journey this has been on.